Accelerator algebra 2 stirrup here. Hey, you just want to go over this projectile motion and talk about the path thrown projectile. Basically, the main equation that we're focusing on here is h at t being the height. It's given by 1/2 gt squared plus v naught t plus h naught. And then gravity is negative 32 feet per second squared. So we can start working these. So therefore, we substitute 32 in for the equation. So half of 32 is 16. Somebody might say, hey, why is that negative still negative? It's because one or the other should have been negative. That was kind of an error on our part. Height is in seconds. Height after t seconds is what we're trying to find. Time in seconds is t and t naught, or the t squared and the t. V naught is the initial velocity, whether it's thrown up being positive, thrown down being negative. And h naught is the initial height. So let's see if we can work through this. So throw and drop procedure with no distal. So if you were to toss a ball into the air, you would have an initial velocity being positive. If you were standing on top of a building and you were to throw something downward, your initial velocity would be negative. And if something just like rolled off the table, just rolled off, it wasn't thrown, there was no force, it just rolled, your V naught would be equal to 0. No additional force applies. What happens to the object? Force on it, well, it's going to accelerate towards the ground. Will the quadratic be the same as the object starts at a height above the ground? We'll talk about that in a little bit too. All right, so how long does it take for an object to reach its maximum height? So we're talking about the vertex here. So once we have plugged things in, we can use our negative b over 2, and that's going to give us our time in seconds usually. And then you plug that back in to find the other part of the vertex, and that would give you your height. And your height could be in feet, miles, and yards, inches, whatever. So how long does it take the object before it reaches the ground? So that means you're plugging in 0, x squared plus bx plus c. When you solve that, usually you only get one time that'll take on the ground. If you're tossing it from the ground, you have the initial, so it's 0. But we'll go over a few of those, which we don't take care of that. And I'm just looking for examples to work because, okay, a cliff diver in Acapulco, Mexico jumps off a cliff into the ocean below. His height is in meters from the water, so we're doing it in meters and seconds. Okay, how should we label the x-axis on the graph? So the x-axis should be time, and then the y-axis should be meters. And being he is jumping off of a cliff, so basically that's the parabola. This side of the parabola we were not going to look at. So if we were to plug this into our calculator, and we can talk about this in class a little bit more, we should probably have our x min be 0, our x max, that would be, a suitable amount. So let's maybe take it out to 100 first of all, but we could probably reduce it down to 50, then down to 25, etc. But let's talk in class about how we'll put this on the calculator, okay? What is the greatest height the driver will reach? Will he reach the ground? Okay, so let's go back to the equation. So negative b over 2a. So I have negative 1.5 over 2 times negative 4.9. And so if we use a calculator on that, let me grab one real quick. So 1.5 divided by 2 times 4.9. So this is giving me at 0.153 seconds. So once the person has jumped 1.53 seconds, been in the air, So at what did I say it was? 0.153. 0.153 seconds. And then we would plug, I'm just making it worse. So 1.53 seconds. I'm going to take that 1.53 and plug it into my equation back here for x. So I'm going to go negative 4.9 times 0.153 quantity squared, or individual squared, plus 1.5 times 0.153 plus 17. Thanks, man. So it looks like 17.11. 17.11. What is the greatest height? So he's 17.11 meters above. So basically this took place here, goes up just a little bit higher, and then so once he's gone 0.153, he's gone to his maximum height. So this is basically going to do this. Okay, this side of the parabola we're going to ignore, but we can go, when will we reach that height? 0.153 seconds. And how long will it take the diver to hit the water? So I'm going to take my equation, which was negative 4.9 x squared plus 1.5 x plus 17. If I set it equal to 0, if I had graphed that on the graphing calculator, what I'm going to do is I'm actually going to calculate a 0, and on the graphing calculator we want to make sure our 0 is as close as possible. And again, we'll work this in class. So it looks like after 2.022 seconds, he would splash into the water. Okay, again, we'll do that in class. Height and feet of the football can be thrown, represented by this equation. What was the initial vertical velocity thrown? So that's V naught here, so 32 feet per second. From what height was the ball thrown? It was thrown from 6 feet. Okay, it's probably the height of the player's arm. How high will the ball be after a half a second? So on our equation, I'm going to go negative 16 times 0.5 squared plus 32 times 0.5 plus 6. So after half a second, the ball is 18 feet up in the air. So it went 12 feet higher than it had started with. When will the ball reach its maximum height? Well, we're going to use my negative b over 2a. So I get negative 32 over 2 times negative 16. So that gives me 32 over 32. So at 1 second after he launches the ball, it'll be at its maximum height. And then estimate, or what is the ball's maximum height? So negative 16 times 1 squared plus 32 times 1 plus 6. So that's going to give me negative 16 plus 32 plus 6. So that's 16 plus 6. So it's going to be 22 feet that it'll go above. And estimate when the ball will hit the ground. So I have 0 equals negative 16 x squared plus 32x plus 6. So if I graph that on the graphing calculator, and we're looking for where it's going to hit the ground. So we're going to go second, calculate a 0. So it looks like at about after the ball has been in the air for 2.17 seconds, it's going to hit the ground. Okay, and again, we can do this in class, so make sure we're asking about it. T-shirt robot fires a T-shirt with an initial velocity of 88 feet per second from the top of a building is 40 feet high. Okay, so this is my V naught, this is my H naught. And so my equation is y equals negative 16 x squared plus V naught x plus H naught. So it's going to give me negative 16x squared plus 88x plus 40. When will it reach the maximum height? So I'm going to go negative b over 2a. So negative 88 over 2 times negative 16. Divided by 32. So 2.75 seconds. It's at its maximum height. What would the maximum height be? I'm going to take 2.75 and plug it into my equation. So it looks like that T-shirt will get up to 161 feet at 2.75 seconds. If the shirt's not caught, when will it hit the ground? So I'm going to go 0 equals negative 16 x squared plus 88x plus 40. If I set that equal to 0, or if I go ahead and solve it, I plot it. So again, ask me, and we will make sure we are covering these in class. Plus 40. So at 5.92 seconds after you have launched it, it'll hit the ground if nobody caught it. So it's been in the air for a while. A football is punted from a height of 3 feet, so that's H naught, initial velocity, which is V naught. So y equals negative 16x squared plus 40x plus 3 is going to be our model. When will it reach its maximum height? So I get negative b over 2a. So negative 40 over 2 times negative 16. So negative 40 over negative 32. And then figure out the decimal. 40 divided by 32. So at 1.25 seconds, after it's kicked, it's going to be in the air, the highest. How do we know when it gets its height? It's going to be our vertex. So it looks like it'll get to 28 feet above the ground at 1.25 seconds. And then if it's not, when will it hit the ground? So again, I'm going to take my equation, set it equal to 0. Of course, I'm going to graph it and find where it crosses the x-axis. So I can calculate a 0. So it looks at 2.57 seconds after it's kicked. It's going to hit the ground. Okay, make sure we have questions. Please bring them to class. Let's talk about them. Have a great day, everybody. Take care of one another. Bye-bye.